Let us strip away the classified radar-absorbent material of this $2 billion machine to expose the brutal mechanical reality hiding underneath. You are looking at the exact structural cross-section of the B-2 Spirit bomber as it penetrates the heavily defended airspace monitored by the Russian S-400 Triumf surface-to-air missile system. The 91N6E Big Bird radar on the ground sweeps the atmosphere with high-frequency electromagnetic waves, a technological dragnet capable of detecting and locking onto aerodynamic targets 600 kilometers away. Yet, this 152-ton flying wing registers on their tactical displays with a radar cross-section of merely 0.1 square meters, generating the electromagnetic signature of a small pigeon. We must isolate the visual spectrum and render the electromagnetic field visible to understand this physical deception. Observe how the microscopic iron ball paint matrix coating the fuselage actively absorbs the incoming radio frequencies, violently converting electromagnetic radiation into dissipating heat. Simultaneously, the continuous aerodynamic curvature of the aircraft, lacking any vertical stabilizers or sharp right angles, physically deflects the surviving radar waves into empty space, starving the receiver of any return signal. But stealth is not an absolute physical state. It is a highly fragile mechanical illusion, and this illusion is about to be shattered deliberately. Zoom in on the central fuselage, navigating directly beneath the reinforced titanium spine. Strip the external composite armor to reveal the rotary launcher assembly. This is a massive, rotating mechanical carousel engineered to hold the heaviest conventional weapon in the United States military arsenal. The GBU-57 Massive Ordnance Penetrator rests inside this dark cavity, weighing a staggering 14,000 kilograms, locked rigidly in place by hydraulic steel calipers that grip the casing with thousands of pounds of crushing force. To deliver this apocalyptic kinetic payload onto a deeply buried subterranean bunker, the B-2 must execute a maneuver that is aerodynamically and tactically suicidal. It must open its belly to the hostile sky. Cruising at a speed of Mach 0.85, flying at an altitude of 40,000 feet, the airframe slices through a freezing atmosphere where the outside temperature drops to minus 60 degrees Celsius. Let us slow down time to a fraction of a second and run a fluid dynamics simulation to analyze the exact aerodynamic consequences of opening these bomb bay doors. The moment the internal bay is exposed to the near supersonic external airflow, a violent high-pressure vortex rushes into the cavity. This sudden influx of kinetic energy creates a massive aerodynamic drag coefficient, threatening to destabilize the aircraft and rip the composite airframe apart through sheer acoustic vibration and structural torsion. Simultaneously, the stealth profile collapses. The flat, unpainted, highly angular surfaces of the internal weapons bay, combined with the massive steel cylinder of the bomb itself, act as a perfect geometrical reflector. They bounce the sweeping electromagnetic waves directly back to the S-400 radar installation on the ground. The stealth pigeon instantly inflates, exploding on the enemy tactical screens with the massive radar cross-section of a conventional F-15 Strike Eagle. Red alarms trigger instantaneously across the integrated air defense network. Let us pause the simulation at the exact moment of exposure and examine the electromagnetic battlefield. The S-400 engagement radar pulses with immense electrical power, projecting a focused beam of localized radiation specifically designed to paint the B-2 exposed internal wiring, aluminum bulkheads, and the sheer metallic mass of the ordnance. The radio waves violently collide with the bomb casing, bouncing back at the speed of light to the ground antennas. The B-2 internal threat warning receivers scream, detecting the active radar lock. The pilots in the pressurized cockpit monitor the electromagnetic radiation spike, their survival entirely dependent on the mechanical speed of the bomb release mechanism. If a single hydraulic valve jams, or if the rotary launcher hesitates for just 2 additional seconds due to mechanical friction, a hypersonic surface-to-air missile traveling at Mach 14 will obliterate the airframe, instantly vaporizing the $2 billion machine into a cloud of burning titanium and carbon fiber. The surface-to-air missile operators now possess a physical target. They have exactly 3 seconds to establish a solid track, calculate an intercept trajectory, and launch a weapon. The countdown to mechanical annihilation begins. Execute the command to engage the internal hydraulic actuators. 3,000 pounds per square inch of pressurized hydraulic fluid forcefully floods the internal cylindrical pistons. These heavy-duty actuators violently force the heavy composite doors open, fighting against the crushing physical resistance of the rushing atmosphere that tries to slam them shut. Inside the newly exposed cavity, the rotary launcher hums with electric power, precisely rotating the 14-ton cylinder of destruction into the exact downward deployment position. The mechanical firing sequence initiates. The heavy steel clamps disengage, releasing their immense physical grip on the weapon. Gravity violently takes hold of the mass. 14,000 kilograms of forged steel separates from the internal racks of the bomber, dropping directly into the freezing troposphere. We track the kinetic payload as it plummets downward, rapidly accelerating toward terminal velocity. The exact millisecond the bomb physically clears the internal bay geometry, the hydraulic pistons reverse their pressure. They slam the heavy composite door shut with bone-crushing force, instantly sealing the aerodynamic anomaly and perfectly restoring the continuous stealth curvature of the outer shell. The massive radar signature vanishes instantly from the enemy screens, morphing the heavy bomber back into an invisible ghost, just as the S-400 targeting computer attempts to finalize a hard lock. The 3-second window of extreme tactical vulnerability closes, leaving the enemy defense network blind once again. But the physical consequences of that payload separation are just beginning to unfold, triggering a chaotic mechanical crisis within the bomber itself. The sudden absence of 14,000 kilograms from the exact center of gravity creates an immediate and catastrophic aerodynamic imbalance. Without a vertical tail to provide passive stability, the B-2 Spirit naturally wants to pitch upward and tumble into an unrecoverable flat spin. To prevent the airframe from ripping itself apart under the sudden shift in mass, the quadruplex fly-by-wire computer system goes into maximum overdrive. 4 independent microprocessors simultaneously execute over 10,000 aerodynamic calculations per second, sensing the microscopic changes in pitch, roll, and yaw. In a fraction of a millisecond, the computers send digital commands to the hydraulic actuators, controlling the 11s and drag rudders on the trailing edge of the flying wing. These control surfaces violently twitch and adjust, forcing the 138-ton aircraft to maintain a perfectly level flight path, artificially stabilizing a design that is fundamentally unstable. Below the aircraft, the GBU-57 Massive Ordnance Penetrator accelerates through the freezing troposphere at terminal velocity, transforming gravitational pull into raw kinetic energy. Let us transition to an internal X-ray perspective of this falling projectile. The outer casing is not standard military-grade iron. It is forged from a specialized ultra-high-strength steel alloy designated as AF-140, engineered to withstand immense structural compression without fracturing. As the bomb reaches the surface, it is traveling at hundreds of meters per second. The moment of impact is a study in extreme kinetic transfer. The dense nose cone strikes the hardened surface of the subterranean bunker, focusing millions of joules of kinetic energy onto an area no larger than a dinner plate. The hardened steel shears through the earth and rock, utilizing its immense rotational mass to violently bore through up to 60 meters of reinforced concrete, a depth equivalent to piercing straight down through a 20-story commercial skyscraper. As the bomb violently grinds through the subterranean layers, the extreme friction generates temperatures high enough to melt standard metals, but the AF-140 alloy casing holds the internal payload perfectly intact. Buried deep within the tail section of the weapon is the electronic brain of the operation, the layer-counting smart fuse. This highly resilient accelerometer measures the exact deceleration, G-forces, as the bomb punches through empty subterranean rooms and secondary concrete ceilings. It mathematically counts each void and barrier, waiting for the precise millisecond it reaches the deepest, most heavily fortified central chamber. Once the primary target depth is achieved, the microchip sends a localized electrical charge to the detonator. This spark instantly ignites the 2,400 kilograms of AFX-757 high explosives packed tightly inside the steel cylinder. The rapid chemical expansion creates a confined supersonic shockwave, generating millions of pounds of explosive pressure that instantly pulverizes the surrounding reinforced concrete into microscopic dust, effectively collapsing the entire bunker system from the inside out. Back on the surface, the tactical reality of the battlefield has shifted. The S-400 defense system, having briefly locked onto the bomber during the 3-second weapon release window, launches a 4ON6E hypersonic surface-to-air missile. A column of intense fire erupts from the launch tube as the interceptor accelerates vertically at Mach 14, its active radar seeker desperately searching the sky for the massive target it saw just seconds ago. But the B-2 Spirit has already closed its bay doors. The aerodynamic anomaly is gone. The external geometry has returned to its flawless, radar-deflecting curvature. The incoming missile seeker is blinded, overwhelmed by the active electromagnetic absorption of the iron ball paint and the physical deflection of the airframe. Unable to find a return signal, the $2 million interceptor missile overshoots the empty airspace and detonates harmlessly in the upper atmosphere. The B-2 Spirit alters its heading, cruising silently back into the dark void, leaving nothing behind but a cratered landscape and an obliterated command center. This is the ultimate triumph of Northrop Grumman aerospace engineering. It is the ability to package the destructive equivalent of a localized earthquake into a highly unstable, artificially intelligent flying wing, and deliver it through the most heavily defended airspace on the planet without making a sound. If you found this mechanical dissection fascinating, ensure you subscribe to DEFUNCT. Leave a comment below suggesting which piece of extreme military hardware we should tear apart next.